All right. Hey, everyone. Welcome back to another edition of the Sourcegraph Podcast. Today, I'm here with Joseph Nelson. Joseph is the CEO and co-founder of Roboflow, a company that's making advanced computer vision accessible to every software team by focusing on developer experience. So you don't need a PhD in machine learning to build great computer vision into your product. You just need to know how to make use of the Roboflow product and API. Prior to Roboflow, Joseph founded a company called Represently, which built software to make congressional representatives more accessible and responsive to their constituencies. And as I understand, he also had a side business using data science to identify opportunities in the Iowa farm real estate market. We'll probably get into that in a little bit. I should call out two personal connections I have to Joseph here. One, I concentrated in computer vision while I was in college, so the problem that he and his company are tackling is a bit near and dear to my heart. And I also happen to grow up in Iowa, where Joseph is from. So that's all to say that given those two connections, it feels like we're already kind of fast friends. And with that, Joseph, welcome to the show.
Thanks so much for having me.
Awesome. So we'd like to kick things off by diving into guests' kind of personal background. And the thing I'm always curious to learn is, for you, what was your entry point into the world of computers and code?
So I guess like the first computer that came into my life was we had the family computer in our house. Mm-hmm. I think like a gateway machine running like Windows 98.
Nice.
And siblings and I would always fight for screen time to play various sorts of games. Age of Empires, Total Annihilation, Roller Coaster Tycoon,
nice.
Things like that. But I wasn't really a, childhood protege programmer of sorts, as you often hear for startup founders. The first time that I actually got into writing, I guess what you could consider to be code wasn't until high school. If you recall, like the TI-84 calculator era, and I don't know if like when you were in school, like these games of like playing Mario and stuff like that kind of went viral among like high schoolers.
Yeah.
And I was a good enough student in that, could play around on my calculator and still seemingly pass classes and whatnot. And one of the things I noticed is that like writing basic programs on calculators, and I don't mean basic the language, I mean like rudimentary, like really simple, wasn't so challenging. So one of the very first things that I kind of cooked up in code was, it wasn't much more than just a dictionary with a random number generator. But what that dictionary with a random number generator was actually a joke generator. So at my high school, and then I think this might have been like 8th grade or freshman year, I don't really know. And at the time when you'd want to like pass games to one another, you would always, connect your two calculators together and then like transfer the games and then kind of go about your way. Well, in the background, I had been working on, without telling anyone else, this joke generator, which like, basically every single day in class, I'd think of like 1 to 3 other sort of like silly jokes. Like, I don't know, like, your mom's teeth are so yellow when she smiles, traffic slows down, or like silly stuff like that like I saw on like TV or things of that nature. And I knew it was important that traceability didn't come back to me in terms of like where this program kind of made its way through the school. And so I just started slipping it into transferring games to one another, because I was one of the first ones to get like Mario into these other sorts of games. And then I would just transfer on their calculator. I don't remember what I called the program, but it wasn't like joke generator. It was something kind of innocuous, like quadratic formula or something like that. So people would just like open it up and check it out. And lo and behold, they'd be hit with these like sort of like funny jokes. And they went like semi-viral through the school. Like people were like, where did this come from? What sort of jokes do you have on your machine? And it taught me all sorts of things about like, like releasing different versions of software. And I didn't have any idea of like version control and things like that. But depending on the day you got the program, you had a different, number of jokes based on how far into the school year we were. And from there, I was like, oh man, like I can make these simple, small things that like bring a lot of delight and fun. And, they were never like particularly like bully sort of stuff. It was actually usually things that kind of brighten people's days and sort of funny jokes that people would share and things like that. And from there, I just sort of like realized that, you could use this for other things like actually programming the quadratic formula or some of these other things where teachers would be like, oh, be sure that you memorize these formulas. And I was like, well, I mean, we have the calculator that can do the rest of it. Why would we do that?
Yeah.
And that was my first foray into that. I remember into writing code.
Yeah. How long did you keep the secret under wraps that it was you who created this program?
This might be the first time it's publicly announced that everyone
really
at Central Academy, it's now on record that joke generator was yours truly.
Wow, I'm surprised that you were able to like. Did you tell any of your friends, or did you just keep it to yourself completely?
I kept it to myself. I actually did a similar thing. One of the first entrepreneurial things that I did once I got to college was I arrived in school right when like Uber was just becoming kind of a thing. Like my first couple of years, I don't think we had. I don't know. Like my first year, it was just coming to campus, and I ran a satirical newspaper. So I went to a school that had something called the GW Hatchet. George Washington Hatchet was the name of the paper. So I ran a satirical paper called the GW Axe. And I ran that on Google Sites because I wasn't like very proficient as a programmer. And that provided enough of like an accessible on-ramp for me to like learn a little bit of HTML and CSS and just kind of hack together a basic word editor, slot in some images and things like that. And I ran the satirical paper, which again, I told no one else at my school was me. And it was really challenging because it was like the coolest thing I'd ever done. And I couldn't tell people, the key thing, which is like, oh, no, that was like actually me. And I'd hear people talking about it on campus of like, did you hear that GW Axe article about George Washington's campus starting construction on construction? Or like, I remember there was this, the GW president at one point was like the highest paid president of like universities. And so he sent out this, email to like the student body that was like, have a happy holidays and things like that. And I identified what the font was. And I still remember it was Avenir font, and then like got the specific, pixel color. And then I like added to the bottom of it, I'll be thinking about you all while I'm in the Bahamas, and like resent that email to like the student body. And that like went pretty viral too. And, I monetized that by when Uber came to campus, circling back to why that's relevant. The ads on the site were like, try Uber. And I had a custom, and still do have a custom Uber referral code because I didn't want to use my name. Right. And early on, they actually just used, short, like, alphanumeric strings. And so I just had this like alphanumeric string that, and I'd free Uber rides for like a year. So that was like another kind of like early programming experience.
Cool. It sounds like you're a bit of a troublemaker. First the joke generator, and then the satirical newspaper / kind of fake email. Would you say like when did that start? Was that just like your personality as a kid always, or was there some kind of like catalyst or trigger there?
Honestly, this makes me sound a lot cooler than I was in school. And the reason I was able to kind of get away with this stuff is because I was like the least suspecting kid. Like, I always got my homework in on time and always focused on like doing well in classes, and kind of kept to myself. And, we just come out and say it. I was, one of the nerds at school. Right. But I had sort of this curious side to me of like, I don't know, why not try some of this stuff? So I wasn't like in school, I wasn't like, like the class troublemaker or something like that. In fact, I was just much more kind of like that quiet kid that, who knows what he's up to and working on, which I think probably made it so I could kind of get away with some of this stuff. Yeah.
That's awesome. So in college, you didn't, despite the success that you had with the calculator program, you didn't go into studying computer science as a major. Is that right? You studied economics instead?
That's correct. Yeah. So my degree is in economics.
Cool. What was that like?
I liked it quite a bit. I mean, the bad joke I kind of make is economics, and then I made kind of like a gradient descent into like machine learning land, where like economics is like a study of basically taking a representation of the world and then oversimplifying it and using equations to try to like optimize that oversimplification, especially microeconomics, right? Like rent. Take rent, for example. Like, if you build more housing, despite what they think in San Francisco, prices will generally go down, right? And we could probably build an equation that like roughly approximate. If we built, 100 more units, might we expect rent to drop even a little bit? And, that's going to be a very brutal, imperfect representation, but it's directionally correct. And then we can like take that formula and optimize it. And so pretty soon, when you start to get into like econometrics, I realized it was like, okay, this is all just applied statistics is all this economic stuff is. And then the deeper I got into like the applied statistics side of things, the more I realized that the programming is where like kind of the action happens. It's like, what model you're using, how can you make sure that things run efficiently? And I guess keeping with my streak now of getting in trouble, like I turned in my thesis in like Python instead of Stata, which apparently like you weren't supposed to do. And the argument was that like, it was less reproducible. And I was like, are you kidding me? Like no one has to pay to reproduce my code. Like here's everything that you need to reproduce my senior thesis and all that sort of stuff. But I took like a couple of CS classes here and there, but yeah, my degree is economics and lots of stats.
Yeah. You were telling me a story earlier about another bit of trouble that you got into involving the chief economist of the World Bank while you're an econ major.
Yeah, this is, I think this is probably the first time I share this story publicly too.
Oh, awesome. We're getting scoops on scoops.
So my first year of undergraduate, the university I went to, George Washington, is in DC. And so they like to kind of flaunt that by attracting prominent professors and people that were in the area. The World Bank, actually, one of the buildings actually happens to rent from George Washington University. Like GW owns it, and they pay rent to the university. And the chief economist of the World Bank at the time, Dr. Kaushik Basu, was asked to teach a game theory class in conjunction with another professor at GW, Dr. James Foster. And the game theory class, you know, is meant to make headlines because there's like this kind of fantastical exploration of all sorts of like scheming and understanding and things like that. Yeah. And what's funny, actually, I mean, to the point of like the dual personality of like both being a good student, but also like try to kind of finding these crevices, I guess. Dr. Foster's wife also taught at the university, Dr. Irene Foster, and she and I were like pretty good friends, and like I tutored for her classes, and she actually advised some of my like research work. And then here I was in like Dr. James Foster's class, and the way the game theory class was structured was there was 2 grades for the entire semester of programming, or I shouldn't say programming in that term, of coursework. Mm-hmm. There was the midterm and the final. And at the time of the midterm, we got our grades back, and I realized that the way the midterm was graded, and I actually didn't realize this is how the class was going to be graded in advance, but the way it was graded was the curve was structured such that the highest score on the midterm was curved to be 100, and then every student was scaled relative to that 100, which, you know, is actually kind of like a common curve that some classes will use, and then they'll be precise about how big they want the center to be versus like the tails and kurtosis and that sort of thing. But what this exposed to me is that if the highest score in the class is a 0 and everyone gets a 0, then everyone gets scaled to a 100. And so in advance of the final, I created this Facebook group, and it was called Game the Game Theory Exam. And I organized a boycott. I said, you know, if no one takes the game theory exam, we all get 100. Yeah. And mind you, I was like this like pesky freshman, and like I wasn't even, I mean, they weren't even like really allowing undergraduate, like young undergraduates into the class. There's like a lot of seniors and juniors, so I was lucky to get a seat. Right. And so I stir up this controversy. I draw like, I'm like, okay, everyone, to be clear, and I want to be on the record about this. Like, I said this to my peers. I was like, you should still study for the exam. Because, you know, this could go wrong, and, you know, you should study. And people were like, well, how are you going to verify no one's going to show up to the exam? I was like, oh, here's what we'll do. We'll show up to outside the exam room, and there'll be 2 Nash equilibria, or like, you know, the concept that we learned in game theory. Yep. One is, you know, we all stand outside and no one enters the classroom, and everyone gets zeros, and the plan works as planned. The second Nash equilibria is one person enters the room, and then we all enter the room, and we take the exam as planned. And so my pitch was like, it's a no risk option to play the game. Worst case scenario, you take the exam just as you planned. Pretty good pitch. So, but not good enough pitch. So I like put this out there, and, you know, I draw like the payoff matrix. I'm like socializing this around, and I learned that there's like international students that weren't on Facebook, and I go like individually visit them and like try to like lobby, and like, it's like I'm whipping votes, up to try to get people to do this. Yeah. And, you know, on the eve of the exam, we get an email from Dr. Foster that's sent to the entirety of the class, but it might as well just said, Dear Joseph, but it was addressed Dear Class. And it's like something along the lines of, you know, It should be known that if someone were orchestrating a broad scale, like they didn't say the word boycott, but broad scale disruption to the way the exam is meant to be administered, that person should know that that's ground for expulsion, academic misconduct. They would lose their scholarships, because that's like how I was like on my like a way to even attend this insane university. And it was meant to be a chilling effect, right? Of like, are you actually going to play this game or not? So everyone just immediately like texts me, emails me, posting to Facebook. People are going nuts. They're like, what are we going to do? Like, what's going on? I'm like, this is the perfect piece that I couldn't have been served a better platter, because I was able to screenshot the email, drop it in the Facebook group and say, in writing, everyone, you can say it's me. Everyone can point and say, this was Joseph's idea and Joseph's doing. And here's the screenshot you need to show in the Facebook group to prove that. And so like, I'll fall on the sword, and that's kind of what we'll do. I'm like full steam ahead. And so we show up for the exam the next day, and, it was a very strange exam day, because everyone's like, chattering, and it's Thursday. And at first, like the first like 5 minutes, actually no one like entered the room. But then finally like someone goes in, we're like, okay, it's over. So we all go inside. And no one was there to administer the exam. The professor wasn't there. And we're like, kind of like, what's going on here?
That's interesting.
And then I remember the TAs like came in from like the back of the classroom, like in this like large lecture hall. And mind you, like I didn't share this, but like the class was like 70 plus kids. Like this wasn't like organizing like 20 people. This was like a mass
substantial
trying to get folks,
body of.
And so the professors come in from the back and just kind of out of nowhere, like 15 minutes late, administer all the exams. And then we kind of, we're taking it as normal and we're doing our thing. The last question on the exam is like, hypothetically, a student in your class organizes a boycott of the game theory exam. Draw the payoff matrix for like what you should do in this situation. Wow. And then the second question, which I think is absolutely brilliant, was what would you do in this situation? Note, the amount of points you get for this question will be equal to the proportion of the class that also selects your answer. So in other words, like if like 70% of the class says they would boycott, you get 70% of the points for that question. And if like, and so I was like, man, that's next level. Like he really got me. It's like, I write like this long essay, like, oh man, like I had some like extra time. I was like, oh, you really got me. That was awesome. Whatever. Yeah. And then I turn in my exam, and then I email Dr. Foster and I just say like, well played. And after that, he ended up like, I think he ended up bumping my grade by like a letter. I don't know. It was a hard fought L, if you will, but certainly a fun experience.
I mean, it sounds like if you hadn't gone into software and computers, you probably could have had a fairly decent career in politics, given the amount of community organizing that went into that effort.
I don't think building companies is that different. Trying to convince people that you can take down the giants and build something of lasting value. Lots and lots of coordination. Yeah.
What got you into, because one of the company that you started before Roboflow was this thing called Represently, which was kind of building software for congressional offices. How did you get into that? Was that something that grew out of your college experiences, or did it come later?
Yeah. It came out of my college experiences for the most part. So you summed it up accurately at the beginning. Represently is software that the U.S. Congress uses to respond to their constituents faster and more precisely. Offices that use the product responded 90% faster. And to give like some scale to like understand this problem, the U.S. House of Representatives receives about 30 to 40 million messages a year. And before our product, they had no level of intelligent sorting. And intelligent sorting here is defined as machine learning based like topic modeling. So like exact text matches and rule-based approaches, those were in use, right? So if you sent a message and it was a copy paste of the same message, those would be grouped in a like-minded way. But if you even tweaked a little bit of the language, that would be considered a distinct and unique note. And Congress hasn't had their staff increase since I think 1974, or their budget for their staff increase since 1974, and are already like pretty chronically underpaid. So if you're like in a position in the House of Reps, like you're basically like the support line you are customer support for the world's most powerful democracy. You know what I mean? And it's like, we don't even equip and so, but I came into recognizing that, because I was one of those interns that was sorting mail. My first year of school, I took an internship on the Hill in U.S. Senator Grassley's office, being from Iowa. Mm-hmm. He's been a senator since like 1981. He's just an institution.
Yeah, I love that guy. He's so folksy.
Yeah, he is. For listeners, if you haven't seen his tweets, or even like Stephen Colbert's segment on Grassley's tweets, you absolutely have to. He writes his own tweets. He's in his upper 80s, and you can kind of fill in the gaps for what you get.
He had a whole tweet stream that I read through once that was like, here's how high the corn has grown. And it was like, 6 or 7 tweets.
Hashtag corn watch.
Yeah, corn watch.
Yeah. I'm following hashtag corn watch right now. It's been a bit of a drought, in where Grassley Family Farms. Nelson Family Farms has been a bit more lucky, but yeah, hashtag corn watch. This year he introduced hashtag soybean watch as well. So
diversifying.
A good sequel.
Yeah.
He has a war with the History Channel for like playing shows that aren't history. So like whenever he turns on the TV and History Channel isn't showing history, he tweets at them and gets upset. It's some high quality.
He's got Twitter figured out to a T.
He really does. And then folks that take Twitter too seriously are in his replies.
Yeah.
But he, So I was actually a press intern, which meant that like, I don't know. Basically, I was like a human Google alert for the office.
Okay.
Like whenever the senator is mentioned, you like cut out the clippings and then like package it on a daily basis. But there was one day
you're quite far from like the House of Cards, power struggles. You were
So back when I was passing the Bush tax cuts. Honestly, like I actually set up a Google alert and it did my job better than I did. So that was demoralizing, but there was one day where I worked as a legislative intern, and I was like sorting mail, and it just sort of stood out to me like how inefficient the process kind of was, and not for any fault of the offices. And in fact, Grassley's office is famous for doing a pretty good job of being really specific and responsive to constituents. Like some offices will have like just one mail they send to everyone that's like, thanks for contacting us. We'll take your thing into consideration. And then there's kind of a slide scale, right? A gradient of how specific you could be. Like you could like actually address the issue that someone wrote in about and then give the office's position back. And, everyone that writes their member of Congress should expect at least a response, and you'd hope, a pretty tailored response. But when you view it from the other side, from the institutional side, and you're so understaffed and such high volumes, you understand why you kind of get somewhat form letter type responses, because absent that, there's just no response possible. And so that's kind of was like first exposed to the problem. But it wasn't until years later where I like picked up a little bit more programming. And then I was actually working at Facebook in 2015. It was my last year of school, but I didn't really want to be done with school. So I basically took like one class at night and then worked full time in the Facebook DC office. There's like 50 people there. It was pretty cool. And Facebook used to host the annual Facebook Congressional Hackathon, which if we could just take a minute to like think about if they still called it that and had that today, like how
hack
crazy.
And Congressional in the same sentence would
and
be
Facebook, right? Like that's already
Facebook.
Like, but anyway, so the annual Facebook Congressional Hackathon, and by annual, I think it happened like twice every other year. And I kind of was like reconfronted with this problem, but the difference was that offices showed up and like came to say things about like the types of issues they were facing and solutions they were hoping to see to their problems. And I was reconfronted with the same thing that I felt as an intern, except this time I felt like I had some level of programming skills to kind of change that. So we kind of hacked together. I don't know if you open source library Spacey. It's an NLP library.
Okay.
It's pretty good. I mean, BERT and things would probably outpace it today, but at the time, I mean, I guess you can use BERT and Spacey, but anyway, Spacey was pretty good for building an off-the-shelf topic model and tokenizing text in an efficient way for identifying when messages were about similar content. And we demoed this to some of the offices. And what's cool about like serving institutions is that it's pretty apolitical, as in like improving the institution, independent of like what the issue is, just generally feels good, right? Like being able to make it so that offices can be more responsive, regardless of what the issue is about, is a pretty agreeable territory. And so that I found that to be pretty cool in that like Seth Moulton's office, Kathy McMorris Rogers' office, Daryl Ice's office,
bipartisan need that you're addressing.
It's a bipartisan need, maybe even like a partisan need. I don't know. And so like we basically built this like plugin that plugged into the CRM systems, because offices had like their own version of Outlook, if you will, for managing mail, and we didn't want to rebuild email. We just sort of built like this plugin, and I mean, it was tackling what I thought to be a pretty important problem. And the funny thing is, like, building a product in this space, you're confronted with like all the hardest things about doing like enterprise sales with like none of the upside in revenue, right? So like
your market size is 538 approximately, plus like 100 senators. Okay.
Yeah. So I mean, this was never. We didn't raise any funding, shockingly, for a market size of 538 and never growing, unless I guess DC becomes a state. So that's a pretty good market to tackle. No, so I mean, we didn't ever want to raise funding and knew it wasn't kind of the market. It's more just solve this important problem. And, but like, it taught me actually a lot about like doing now like enterprise-based deployments. Cause like the entire product had to run on-prem. Like you basically, if you want to sell your product to the house, you have to comply with a very specific set of like IT Schedule 70. Well, not exactly IT Schedule 70. The Congress has sort of exempted themselves from that conveniently, but you still have to like deploy to the Ford House office building, where they basically just give you an empty Linux box and they're like, go. And so like,
you like you plug in your USB dongle into that machine or whatever, and then just like manually set everything up.
Yeah. I mean, like we could SSH in, but like but like the deploy, like, so for example, like
they're not using AWS.
Yeah. All these things we take for granted. All these things we take for granted, like we had to recompile like TensorFlow from source. We had like very limited RAM and just like hardware storage. If the app got very popular, like for example, during the Syrian refugee crisis, that was like during the time of when the product was live, offices were using the product like really heavily, and like it just stopped working. And we had to email someone to get more server space, right? Like that's like, wow, that's like the world. Yeah. Right. And like, please, sir, can I get some CPU? You know what I mean? Like just kind of crazy. But it was a really, really rewarding problem to tackle for the same reason. And ultimately, like what ended up happening with Represently was, we grew it to 9 people, this bootstrap sort of thing. And once the product problem was solved, so to speak, it became very much like the like who like sales thing that kind of exists in political circles to some degree. And that problem was a bit less interesting to me. And again, like I was optimizing much more for driving impact. And so another company in this space that runs a CRM that we integrated with, called Fireside 21, they've rebranded to Fireside, acquired the product and then incorporated it, which meant that like overnight, you could be in 110 offices for like their addressable market, which like was a really, really positive outcome, both for us to like be able to cement the progress that we made, just as much as like driving the impact for Fireside. So all in, that was like 2.5 years, and it was like a very bumpy journey. Like I had no idea how to build a business, and I still don't, right? But we're all sort of getting on,
figuring it out, like us, we all are.
Yeah. No, I mean, but like, it was all sorts of like different pivots of like who are we servicing and what should it look like, and
what was the path from that to Roboflow like? Because you had a couple additional stops along the way, right?
Yeah. So I mean, I had worked on a number of products that like during school here and there, and software products that like never were really meant to be businesses. And frankly, like Represently really wasn't necessarily meant to be a business either. It was like technology solving a problem. And then it turned out that like building a business was an effective way to continue to solve that problem. But then after that, like it became abundantly clear to me that machine learning and its ability to empower and improve all parts of the way we interact with the world around us could be possible. And while building Represently, I'd actually been teaching concurrently for the first portion of the business at General Assembly, which is like one of those code boot camps. And I did that because like initially, like I said, like Represently, we didn't raise any funding. And so like it was sort of this like nights and weekends bootstrap sort of thing for me for a while. And after deciding to work on Represently while just finishing school, I didn't really have any like nest egg saved up to work on. So I was teaching concurrently while building, and then eventually like we had enough customers and momentum and whatever to just focus on building. But the other thing that I saw at General Assembly as a common trend was the impact of empowerment, of giving access to machine learning to a populace that might not have been able to use that technology before. And at General Assembly, like I launched they have a data science immersive program, and it launched in DC and San Francisco concurrently. And I launched like the DC program and taught like 4 12-week cohorts of it, which was a lot of fun, but also gave me exposure to like, again, like a wide swath of not just technologies, but their applications too. And so both these things sort of kind of further cemented that like, this is going to be a wave bigger than the internet, bigger than the mobile phone. And I didn't really know what to do with that, to be honest. After Represently, but before Roboflow, I just toyed around with like a bunch of different projects. Like, did like some consulting work on, I don't know, like I like did some work with Google to write like TensorFlow docs and like kind of like developer advocacy, freelance sort of stuff. Worked on a text project for a financial company. Worked on like a credit risk engine for like a startup. And then one of the projects that like I was kind of attracted to, and you alluded to this earlier, was building something that would help value and sell farms, which I thought would probably be something that I might work on for a bit. But the broad unifying theme here is taking machine learning and applying it to a domain or a sector that doesn't previously have it, so that it unlocks unrealized potential for that sector, whether that's folks that want to have access to credit or people that want to be able to, sort through mail more effectively, or valuing properties to make it be easier for real estate transactions and rural empowerment to exist. And I'll talk about kind of how that turned into Roboflow, but I know you kind of want to talk about the farms thing too, and I'm happy to share.
Say more about the farm thing, because that was really interesting to me. And you come from a family, your family has a family farm in Iowa, right? And
Nelson Family Farms.
Cool. So it kind of runs in your blood. Was this project like a thing to help your family like manage their real estate holdings, or was it something different from that?
I wish. That makes it sound so official. Like NFF in our real estate portfolio. Yeah, hardly. You're
actually more like a big multinational conglomerate that just has a family at the fronting the thing, right? No.
Yeah, no, I mean, meanwhile, Doc Nels, my dad, doesn't even know how to use Facebook, right? Like we're a pretty humble operation. No, the being exposed to the farm growing up, but to be clear, I'm like a fake farmer. Like I grew up in West Des Moines, but my family would go to the farm with some frequency. But this sort of came from one of my older brothers was at a farm auction one day. And at a farm auction, they were auctioning off 4 80 acre plots called sections. And these 4 80 acre sections were adjacent to one another. And the southeasternmost plot had a river running through it. And there is somewhat of like a debate about how to value that plot, because how much of the land was tillable. Was like arable land that you could use for productive agriculture purposes. And, he phoned me, and I was in DC. And I was like, I don't know, like, you're at the auction, man. Like, what do you want me? Like, what do you want me to do about this? And, I thought about it. I was like, well, you could actually probably drop pins on Google Maps and like kind of get an idea of like roughly, how big of an area.
Tracing around the river.
Right.
kind of. Okay.
And then like apply a discount factor of like, okay, let's assume the river takes like, I don't know, 20% of like the arable land. And then like, if the yield is equal to this amount, we'll then just do 80% of the yield, right? Of like the adjacent plot. And so like we kind of like joked about doing that, and he's like, okay, yeah, that makes some sense. And then he goes to the auction on the day of and actually puts in a bid. And ultimately, like the plot was being valued at like a significantly higher discount factor than even the most conservative estimates of like how much of the land was truly tillable. And so like was able to purchase it at somewhat of a discount. This like relatively, like 80 acres is actually a relatively small plot in all things agriculture. And, you know, fast forward a little bit, it became clear that this was like a really good transaction. Like there was a discount factor that was out of whack with probably the amount of tillable land. And I kind of got to thinking, I was like, that can't be one off. Like that's got to be happening all over the place. And so I kind of went digging a little bit deeper, and I discovered that like the data for these problems is in pretty disparate places. So Iowa is, you know how like in real estate, they're like Manhattan is the best place for owning because like property values will never go down in New York. You're in US and New York's always desirable. Iowa is the Manhattan of agricultural real estate. Okay. So with that in mind, property values are generally fairly high, and there's pretty good data, but that data is really spread out. So the U.S. Department of Agriculture maintains data on like soil surveys and things of that nature. At the state level, you have data on, in one office, you have like the transactions record of like how much something sold for. Iowa State University, where I know one of your parents, maybe
my dad went. Both my parents went there actually. Yeah.
They're a land grant university and actually helping farmers, as we say. They maintain a really robust data set on the yields and something called crop suitability rating, CSR. And now we have CSR 2.0. But the thing is, this data is in disparate places, and it's kind of hard to bring together. But that's a really good thing that like technology could help do in a relatively costless way. So I built like a bunch of scrapers that kind of brought together this data in disparate places. To get the sales data, you actually, they don't post it. You have to call, and Iowa has 99 counties. And so like, you know, I found like some help and Upwork and whatnot to like kind of fill in that piece of data. And so then I basically just built like a really simple regression, right? Just kind of this joke that like all AI is just regressions at some point. And then I looked at and saw like the points that are furthest from the line are the ones that are probably the properties that are most attractive for investing in over the last 3 years, right? Properties that are compared to the amount of yield that they have, the soil quality, and these sorts of attributes and prior sale prices. Those are places where you should consider purchasing. And what was another interesting finding is that like, okay, so that must be like a slam dunk thing. What I also learned is that like the customer, for purchasing these properties, agriculture investors, at least like professional agricultural investors, discounted this pretty heavily because they're like, well, there's probably either something wrong with that, or like the prior price is like indicative of like the future price and things like that. And so like, and ultimately price is like, what is something worth? It's worth whatever people are willing to pay, right? An NFT JPEG is worth whatever people are willing to pay. And
indeed, yes.
And, you know, you can balk one way or another, but what people are willing to pay is the price. And so professional investors in agriculture, like kind of discounted what I was working on. But I found that, investors that wanted exposure to agriculture that previously didn't have exposure to agriculture, didn't discount these sorts of findings. And so like I basically put together this almost like 3-page, like good looking PDF of like why to add agriculture to your portfolio. And basically I ended up like shopping around like these, properties that folks should consider purchasing. And the deal was, you know, the way it kind of works is if you buy a property, you owe $75,000 on the day of that property, on the day of close, liquid, and then you owe like the full amount within 30 days of the close. And so you basically could, in theory, find one of these properties, get someone to like verbally say yes, secure the first part of the transaction, and then do the rest of the transaction like when the property actually kind of changes hands. And there was one real estate investment trust REIT in LA that really bought into this thesis. There's also like a tax advantage where if you sell a property, you can 1031 exchange into another place, and all these sorts of reasons why this is actually like a pretty compelling business model to pursue. But it wasn't until, there was a transaction where like, I did my broker's license and I kind of introduced kind of like buyer and seller and was like kind of cut out of the transaction. I had no recourse because I can't claim.
So you're essentially a market maker. You were connecting like people wanted to invest in this form of real estate in LA with folks that wanted to sell farmland in Iowa. But you it's not like you were sitting on this giant pile of cash saved up from your Congressional intern days or anything like that.
No. Okay. And like Represently allowed me to like have time to choose what I wanted to work on, but I couldn't buy multi-million-dollar plots of land just for fun.
Got it.
But yeah, I mean, and the funny thing is that like one of the reasons I didn't want to work on this was at the time, I didn't want to enter what seemed to be sort of a legacy industry. I actually at the time didn't want to move, dare I say, and things like that, which is sort of funny now given how much time I spend both in Iowa and kind of all over the place for like our team and whatnot. But a friend of mine actually like kind of built a business around this, and I've been very supportive of him and his efforts. So
that's awesome.
It's a win-win.
Cool. So it seems like you had so much experience applying like statistical analysis techniques and machine learning to various domains, but it seems like everything except computer vision so far. So how did you get into computer vision, and what was the backstory of Roboflow?
The backstory is a childhood friend of mine from Iowa, and now my co-founder Brad Dwyer. In 2017, so when I was working on Represently, he was running a company in the social game space called Hatchlings, which is a Facebook game at like the Zynga era type game. And Brad and I are like surprisingly similar. His company started out of a hackathon. He like didn't really mean to build a business, but ended up building this large bootstrap thing.
Nice.
But he phoned me, and you say there's kind of no computer vision background. In fact, in 2017, when ARKit had come out, Brad had this great idea where he was like, what if we built an application that solves Sudoku puzzles for you? So on your iPhone, you'll hold it up over the top of a Sudoku puzzle, and then it relays all the solutions in augmented reality. So you can see like live it being solved right before your eyes sort of thing. And Brad's a super talented developer. And at the time was relatively novice to machine learning stuff. And he was like, oh, who would I know that do machine learning stuff in my life? And so he phoned me up. And he's like, hey, what do you think about this idea? And I was like, man, the digit recognition is the hello world of computer vision. Like, MNIST data set, reading digits, no problem at all. The ARKit side of stuff, I don't know a whole lot about. But, he kind of took the opposite approach. He's like, I don't know. The ARKit stuff is the easy part. The computer vision stuff is going to be the hard part. So basically 30 days later, we have this thing thrown together that like Brad builds and releases and calls it Magic Sudoku. And it wins Product Hunt AR App of the Year, catches a lot of people's imagination, and had a really, really great user experience and kind of exposed what was possible. Like we carry around these pocket supercomputers. Our cameras are better than, the digital professional cameras that you'd buy even 5 years ago, and it's just in your pocket. The processing power of a phone, even a TI-84 calculator, is better than we use to land on the moon. And like, the intersection of all those things hasn't really changed the way we interact with the world around us. And so we figured that like this would be like a small glimmer of like what's possible when we threw together this like computer vision AR thing. And, we put it out there and it was fun. But that's kind of all it was meant to be. It was just like two hackers that like to tinker with the new technology. Well, then you fast forward a few years and, I'd exited where I was working on with Represently, and I was kind of toiling around with these other sorts of technologies. Brad appointed a new CEO at Hatchlings, and summer 2019, we kind of linked up and got to thinking about why didn't Magic Sudoku release this wave of like developer inspiration of making things way more fun to interact with? Like, why didn't that happen? And it didn't seem like there was an obvious reason for it not to happen. So we're like, well, maybe we should work on making that happen. And so originally what we were working on with Roboflow was actually making board games more fun to play by adding like software features to real world, in this case, board game objects. building on the success of Magic Sudoku, because we sort of had some history there. Board games are social by default. There's no barriers to entry except for like brands to some degree. And so we're like, if we first make board games programmable, that can be like an SDK within release. So then other developers can make new rules for these board games. And then we'll release SDKs for every other object that you see in the world around you. And that was kind of like the initial game plan of when we started kind of hacking on things together.
So the problem you're tackling is making like AR enabled board games or like an SDK to enable more game developers to kind of like bridge the gap between physical and virtual world in the context of board games.
Exactly.
Okay.
Exactly. Yeah. Really, really succinct, eloquent summary.
Yeah.
And the insight was actually that like it's not the AR that makes things special, if you think about it. So Pokemon Go is a fantastic example of this. It's the go-to example for AR games, and that's really frustrating to me because augmented reality doesn't enhance the game experience, or it's not like required for the game experience at all. In fact, you can turn off the augmented reality portion and the app still works the same. Like the Pokemon just exists in like the environment you're in, but it doesn't do anything that like intelligently interacts, right? Like why when I open Pokemon Go doesn't it see water and like go swim or see a tree and like sit in the tree or like they're like, so it's the intersection of not just augmented reality, but like having context. And that's what vision unlocks, right? Vision unlocks the context of the environment that you're interacting in. And so we kind of realize is that like computer vision is like what makes a lot of this stuff interesting and differentiated.
Yeah. And what was the state of computer vision at that point?
We had there were models that could run on mobile devices. Apple had recently acquired Exnor, like a Seattle-based startup that had worked on technologies for mobile-based vision technologies. There were open source models that were seemingly quite good, but there wasn't really any developed tooling. And arguably kind of still isn't, which is why that's what we're working on. And
it's kind of, you had to like roll your own model essentially. Like you had to have some sort of domain expertise to get things. It's almost like a black art or like black magic a bit.
Yeah. So like, exactly. So, let's take, for example, the next app we released after Magic Sudoku was one called Board Boss, which is still free and in the App Store. So it's actually a fun one to try out. And what Board Boss does is it solves Boggle. So in the same way Magic Sudoku solved Sudoku puzzles and relayed those solutions for you, but that completely ruined the game, to be clear. Like Sudoku was ruined. Like you couldn't. It wasn't like
that's
give me a hint.
The whole point of Sudoku is you're the one figuring it out.
Yeah, it wasn't like give me a hint to solve this puzzle. It was like I'm going to ruin the puzzle. And so we realized maybe that's like kind of like a cool party trick, but maybe not exactly what like our users wanted. And so like with Board Boss, we're like, okay, Boggle is a board game where if you had an omniscient AI, right, that could like see the state of the board. And Boggle is the 4x4 word game where you try to find word combinations among adjacent letter tiles. Humans will find some subset of the total possible words. An algorithm, like a breadth first search, would, checking against a dictionary, if it's given the inputs, would find all of the potential words. And then we could use augmented reality to overlay that on the board and show you, and you could get better and play and all these sorts of things. And to do that, like the process by which we had to like put things together to do that is we had to capture a ton of images of Boggle boards. And there's variations of Boggle. I learned there's big Boggle, there's like little Boggle, there's 4x4, 5x5. There's different lighting conditions someone could be playing Boggle in from different distances. So you got to account for all those things. Great. Now you've got your data set. Now you got to label it. So you got to annotate all those dang individual tiles with the letters that you want. And
this is giving me flashbacks to my research in college. It was just like a lot of work, just to like do, not even like figure out the logic of like what to do on the board, but just to like read the damn Boggle board.
Yeah.
It's like a full-on research, like a thesis.
Yeah. Basically, you're like spending all your time before you even get to do like quote unquote the fun stuff, or even like in our case, what we considered to be the domain problem, which was enhanced board games. We're not even close to that yet, right? So then you got your data, then you got it labeled, and then you can select your model. And at the time we were working on stuff, and I know this was similar-ish to when you were doing your work in grad school. They were kind of like off-the-shelf leading architectures, so you didn't have to totally reinvent the wheel on the architecture side of things. And that's only accelerated, to be clear. So you could kind of choose an architecture that like you didn't have to do a whole lot with. Like you didn't have to learn, but like you still have to learn arguably more than you want to like hack together and figure out the data format and like the annotation format, and then like how to train the thing, how long it needs to train, is it overfitting, all these things. And then you've got a model on the other side. Then you got to deploy the thing. So you become like an embedded firmware engineer to figure out how to get this thing working in an app. And then you can put your mobile app development hat back on, and you can go back to being a mobile dev to then like making an experience that's like excitable and fun. And then you're not done, by the way, because once your model's out in the wild, it's going to encounter new conditions. There's going to be different Boggle boards and different letters and different lighting. So you want to continue to sample. So you got to build some way of continuing to like report feedback from users and then like do this cycle all over again. And so we had built that pipeline internally with our own sort of hacky internal tools. And we then, after Board Boss, wanted to release one for chess. And keeping to our hackathon selves, we went to TechCrunch Disrupt 2019 to release Chess Boss. So we roll into this hackathon. We've got our chessboard, we've got our photo, like our cameras and tripods. And like, we're like borderline too old to be at the hackathon, So it's like us and like these Berkeley kids, and then folks that are like way too old to be at the hackathon, So it's like, we're there.
Right.
We're borderline. And so we throw together, Chess Boss in 48 hours, because we'd experienced and encountered a lot of these problems before. And then the highlight of Chess Boss is, I don't know how far into judging it made it, but like it made it far enough where Evan Spiegel came along to like look at all the projects, and he like stood at our table for a little bit. It was like, oh, that's neat. I could see myself using that, and kind of like walked along, And we got like a little, photo op, and like that's the peak of Chess Boss.
It was good enough to catch his eye and make him linger a bit at the table. Yeah.
And I mean, it's actually a really cool demo because like you have the phone point at the board, and what Chess Boss does is the same thing that the other games do. You could take a photo of the board, and it will understand the state of the board, and then make a move recommendation using an open source chess engine, Stockfish. But what we realized, like between these experiences, was developers don't need more inspiration; they needed our tools, right? Like the internal process that we'd painstakingly kind of reinvented. Developers have like you can talk to any company, and like they've sort of either built this themselves in house, or they have like a Rube Goldberg machine for like getting to production. And like if Sarah leaves, the whole thing comes crashing down because like Sarah knows how to like get models into production. And so in fall 2019, we went all in on like, okay, what would it be like to like productionize our internal tools and release them externally? And so in January 2020, that's what we did. And so Roboflow is basically like the toolkit developers use to build computer vision into their applications. And the other thing that we've been working on is that like, to the point that you were describing, and I was talking about with like collecting data, is like, why even start at the point of like assuming everyone needs to start from scratch? Like, why couldn't we release like even models? So like if you're working on a problem that like someone has already built a model for, let's make that easier too. Because there's like a lot of things that people end up working on at the same time. Like the number of Roboflow users that have worked on like solving bananagrams or like sushi identifiers or like canoes, like all this stuff. Someone's probably done it before on Roboflow. And so like making that easier so that you can start from where someone else left off and then just use the tooling to improve from that checkpoint. It's kind of like the next wave of making it even easier for engineers to embed vision in their applications.
That's cool. Are you trying to become kind of like the GitHub for computer vision models? Like build up a community where people can kind of share and learn from one another in creating these models?
What open source? I know that's like what open source code or what open source did to code, we definitely want to do to vision, right? So like make it easier to get started, make it easier to collaborate, make it out in the open, allow developers to build on other developers' experience. So absolutely. Brad pointed out, he was like, GitHub for X. He's like, that's like a Rorschach test, like the psychology test where like they hold up the blobs and like you see in the blob, like you want to see in the blob. Yeah. That's what he's like, GitHub for X is that. And I was like, that's really true. And so for us, like the GitHub for X is like, yeah, it's the community parts of GitHub. It's the collaboration. It's the ease of developer experience. It's focusing on the developer as the key person that's going to usher in this evolution. Cause like vision is going to affect every single industry. And it can only get there if folks that are domain experts and engineers and building that future have access to it. And so if we can like accelerate that timeline, then we can bring a lot of progress beyond just board games, but, you know, cancer acceleration or manufacturing processes, retail checkout, all these sorts of things.
What is the range of applications or companies that use Roboflow today?
Extremely broad. So we've had a little over 50,000, at least at the time of their recording, a little over 50,000 engineers have built with Roboflow. Over half the Fortune 100 have built with Roboflow. And we like to joke that the scope of problem is everything from under a microscope to in the next galaxy. Like we have projects of people that are analyzing images in petri dishes just as much as people that are identifying stars from telescopic captured images. And the size of companies ranges from like solo hobbyists and hackers, kind of like us and how we got our start, to some of the world's, you know, most advanced and largest companies, like Walmart, right? Like literally the world's largest employer. And so, what's interesting is that like when you see a technology like that like so many groups benefit from, you know, it's special and it's not just a blip on the radar. And going back to like why Roboflow as opposed to like all these other things that I was working on before, the thing that's really resonated with me is that like by making developer tools, it's the end user who determines the impact that computer vision is going to have in their field. Instead of us trying to say, oh, you know, we're going to make the world's best like physical therapy app. So like every person that goes to physical therapy can get targeted recommendations on their moves and all this sort of stuff. You could do that. By building the tools, you enable that and every other use case along the way. And I find that to be like extremely empowering. And it basically like has helped me go from, okay, you know, we could focus on this one sector, this one thing, but if we enable anyone to build for the end goal that they're working on, our impact is, you know, 10, 100, 1,000x, whatever sort of trope you want to use.
Yeah, that's awesome. So what does developer experience for like computer vision look like? Yeah, because when I think back to my, you know, research days, it's like, okay, fire up MATLAB, and then you like you said, you have this like data pipeline, you have a bunch of hand labeled images, and then you select a model, and then you try to train that model. Then maybe there's like some amount of feature engineering. In my mind, it seems hard to disentangle all that from like the end product that you're building. So what is the separation here? Is it like an API that people can call into? Is it like a set of library dependencies that they kind of npm install into their application, or what does that look like?
It's a good question. We try to lead model first, which is going to be if you're building like a web app, like an npm package you want to use in your browser. If you're deploying to the edge, like on like these NVIDIA Jetsons, it's like here's a Docker container that contains your model, and like it's just going to run in the way you would expect. If you're building like a internet connected web native, but not like browser native experience that like doesn't need a stream webcam, but still is going to be internet connected, you could just serve up an API. And that's kind of like the place that everyone wants to get to where they can use their model, get value from it. But, you know, like those kind of iceberg images, there's a lot that needs to go into getting there. And so, the best, you know, kind of first class experience is like you have something that you can immediately embed in your app. And that's what we want to get to. But just as we were describing, like what your model is seeing, it could be very, very different than what your model has been trained on so far. And so that's what the rest of the tool chain is like, okay, how do you make sure you're continuing to collect images that are representative so your model can continue to improve? Organize them so that you can focus on labeling the ones that are only going to improve your performance. Actually being able to do the annotation. Being able to train a model on either an automated basis, like, hey, retrain every time we have like, you know, 1,000, 10,000 new images, or on a way that you want to determine on a schedule you just want to say when you want to train it. And so like making it extremely easy for someone who's already a software engineer or technical to some degree to incorporate into their product, and then kind of working backward from there. Now, not everyone has kind of like a pre-trained thing they could start from, right? So some folks do have to start from, okay, how do I get images of the thing that I'm working on? And so like that might rely on, we have like an upload API that you can embed into your app. So like if you have, I don't know if you remember like the 30 to 50 feral hogs meme, that kind of like swept Twitter.
I remember that meme.
We had someone that was using his cameras in Texas, in West Texas, to identify 30 to 50 feral hogs with Roboflow. And so he started with his endpoint of having his like hunting cameras, and he wanted to know when and where the feral hogs were on his property. And so he like hooked into his cameras like an API that just uploads those images. So he like has the ability to start to do collection and build a data set. And so again, that's like a developer centric first starting point experience. Is like, if you don't already have a model you can start from, how do we make it easy to kind of programmatically collect and interact with the pieces you've already put together? It means being very open as well, right? Like making it easy to integrate with like any camera integration or like run on any device you want to run it on. Label wherever you want to label. Like you don't have to, you can self-serve label with us, or you can, farm it out to any of those managed labeling services and get the data back in a format that you can then work with. All those things matter to us.
Do you like of the like? I guess one of the maybe like first order decisions in spinning up computer vision for a particular application is model selection. You have to choose which model is going to be the thing that you use. What's the range of models that are available to work with on Roboflow, or is it sort of thing where like you can kind of define your own?
Yeah, that depends on the user's level of their background in the space. So if a lot of our users are pretty pragmatic and they're like, let me use a model, try it in my app, try it on my data set and see if it works sufficiently well. And then they're like, okay, Roboflow, I will rely on Roboflow to know and continue to basically, as the state of the art improves, make it so that I can rely on Roboflow to continue to incorporate that state of the art. There are other teams that might be more advanced that want to do some of their own set of custom modification stuff. But the truth is that kind of the state of computer vision is models are increasingly better, faster, and open source. And the question becomes much less like what architecture you want to use and much more like how do you embed that capability in your product and use it on your data. And so there's like a funny debate in like computer vision land where like kind of models have developed almost like sports team levels of fandom, which is like
Emacs versus Vim.
Yeah, a little bit. Yeah. Like, are you on like efficient debt? You're using like YOLO v4 or like YOLO v3, like YOLO v5s. Like, where are you at? And that's fun. But the truth is that like at the end of the day, for your business application, what you care about is one that's within the performance expectations you expect, both in terms of speed, latency, size of the model, the fit wherever you want to run it. And there's not like, in the similar sense to like, there's not like a uniform one is best for all situations. It's the same is true. Like models come with trade-offs too, of like the size of the model and some of those sorts of things. Sure. So we often encourage users to like think about like deploy centric, like what are the deployment conditions? Like, are you able to run it server side, or does it need to run at the edge? Like all these sorts of things factor into the consideration. And then we actually try to make that be even less of a concern for the end developer. So like, tell us where you're going to run your model, then we'll help you optimize to find the best performance for that given deployment target. And then, I mean, that said, there's a broad ecosystem of models that are available, and we kind of maintain an open source model library as well on models.roboflow.com, where users can try out their data set in any of the models that we're sort of discussing here. Any of the different YOLO models or things of that ilk.
Yeah, Joseph, as I understand it, you have kind of a demo that you can show off of Roboflow in action. Is that right?
Yeah, so I thought it'd be cool to show Roboflow Universe, which is like the community space where developers share both their data sets and like their pre-trained models out in the open. So like if you were starting a given problem to say like, I don't know, maybe you want your Nest camera to text you when you get a package, or you want to see when there's like a given animal in your backyard, and then you want to use Twilio to like send yourself a text or something like that. You could go and collect a bunch of images of either those packages at your doorstep or, that squirrel in your backyard. Chances are maybe another developer has already worked on something similar. And so if you could start from their model or their data set, then you could probably have your app up and running more quickly. And so Roboflow Universe is kind of like that community space. And I thought it'd be cool to demo kind of what that looks like with an example model
Cool.
from Universe.
Cool. Awesome.
So I'll share my screen. We'll see how this goes.
Cool.
So I've gone on over.
So this
Yeah,
is
go ahead.
Roboflow Universe. This is kind of like the community space that you were just that you mentioned is kind of like a forum for kind of like sharing models publicly. So like any user can come on this and like build a model and then share it with other people who might be interested in checking out that same model.
Exactly. Yeah. So the model or the data set. So for example, like one person, Ritesh Kanji, he's like a YouTuber with 90,000 subscribers. He has this data set and model for like playing card detection. And so you could like take this model and then build it into your app and make like, I don't know, like a smart poker player or something that like automatically counts cards for you or something like that. Just using this model, which is already trained
Awesome.
and clearly recognizes cards and their suits. And then there's, I
Awesome.
mean, the theory is that like, computers are going to see kind of everything over time. So if you can enable people to get a head start, then there's some pretty cool stuff people would make. One of the models that we're kind of fond of at Roboflow is this raccoon detector. So
Okay.
the raccoon's like a unofficial mascot at Roboflow. One day it'll be graduated to official, I suppose. But you can see here, like this model's been trained on a bunch of images of like raccoons in like kind of funny contexts too.
A lot of pose variants there. You got like, oh wow, you got occlusion. You got
yeah, and like this data set's not giant, so it's not like the most robust model, like 196 images.
okay.
But nonetheless, like the model finished up training and we got some good metrics here. And so you can try this model in a couple of different ways. Like you could use it via like a hosted API if you want to have like a little web app. You could deploy it to
cool.
the edge like on a Jetson or something called a Lexonis Oak. I'm going to click here, webcam. And what this does is it uses Tensorflow.js to load the model completely client side. So the first page load is kind of hefty because it's like moving the full model to the edge. But from now here on forward, this is using my local machine's resources and no data is being sent back to any sort of server. And so this model is looking for raccoons and I come prepared. So like,
Oh wow.
so here, I mean, and you can
That's
tell like
awesome.
actually it doesn't, let's see, I mean, how far away I can get here. Yeah, so the light there starts to make it a little bit more challenging.
Yeah, yeah.
And which makes sense, right? Like most of the images that we saw, the raccoon was like the majority of the image.
Yes.
And even Flatcoon looks like it does a pretty good job of finding. But like,
That's awesome.
this like is now an example web app where I could just include this on the source code, and then I could call this model and pass any canvas on a web page to this. And that canvas obviously could be maybe a video that someone loads into a web page or any sort of image or any sort of stream.
That's awesome.
And so, yeah, well, raccoons are sort of like the example we find to be pretty fun. Over time, there's thousands of projects that people are making, and then we kind of curate the best ones and list them publicly for users to get going.
Is there a backstory to why the raccoon has become the unofficial mascot of Roboflow?
I wish there were, let me stop my share. I wish there were a more fun story, but it's kind of a couple of different origins. One is that like one of the most famous data sets that someone used for custom object detection in TensorFlow, they actually like hosted a bunch of raccoon images. Someone named Dat Tran. And so like we sort of adapted that. But then over time, like we've kind of like back propagated reasons why the raccoon makes sense. Like for example, Roboflow cleans up like your trash data and raccoons eat like trash, or like raccoons are like sort of these animals that are like very curious and like don't like to be in cages.
That's awesome.
So at Roboflow, we have a very curious culture. And so I don't know. It's
Yeah.
become like an unofficial company value of saying like we are raccoons, and it's kind of silly, but it hits to these points of the importance of thinking a little bit differently and maybe being a healthy amount curious.
Cool. And
Awesome.
then, so Joseph, how do people actually like create models in Roboflow?
Yeah. So what we showed there was Roboflow Universe, the public space where once you've created a model and a data set and you've labeled it, and maybe you and your team are ready to share that in a public way, like for hobbyists and students and public research projects, they end up on Universe. But that presumes, you've already collected your data set, you've labeled it, you've done model training and all that stuff. And that's kind of like the Roboflow core product, is enabling people to train custom vision models. So I thought it'd be kind of cool to maybe show what that looks like a little bit. So here I've created a workspace, and I did create a public workspace. We can, of course, create private ones for business critical data, but I thought it'd be fun to show, kind of inspire hobbyist use cases. So
Cool.
I'll create a project here. I'm going to be doing like chess piece detection. I'll call this like chess pieces detection. I can assign a license to this project. The project type is going to be bounding boxes, and we're going to be looking for pieces in our chess images. And so like I've got a bunch of like images of chess pieces locally on my machine here. And the name of the game with like the problem that we're hypothetically solving here is training a model to identify those chess pieces and where they are on the chessboard. So
Got it.
with Roboflow,
So
I
all
can
these
upload
photos, just for the folks that are listening, all the photos that you have, they're essentially photographs of a chessboard with pieces in different configurations.
Yeah, that's right. That's right.
Cool.
And so I can drop those chess images into Roboflow. I use the web interface, but you can do that via API as well.
Okay.
And what's kind of neat here is, either you could come with annotations, like you might already have a place where you got your images annotated, and I could add those annotations to Roboflow, and Roboflow maps those up for me. You can kind of does a quick check, and you can see everything kind of looks good. And then I deliberately left one on annotated image here.
Okay.
And I can go ahead and upload those, create a train test split. Now, even though you'll see there that I annotated everything except one, because I wanted to show, what if you have an image that you needed to add annotations to?
Yep.
Go ahead and open that image up, and then all the annotations that are already with this data set are associated with this one. And this is a black rook.
So you have a labeling interface in the app itself.
That's right. Yep. And one thing that actually is pretty cool is you can actually like have a model automatically label these images for you. So instead of like manually drawing all these images or drawing all these bounding boxes, a model could automatically apply them. Or you could like farm them out to a third-party annotation tool. Like there's plenty of companies that will like take your images, label them for you, and send them back to you. And that's a common workflow we see when people start to get like quite a few images that they need to have annotated and ready.
Yep. Makes sense.
But yeah, I mean, and then from there, kind of the standard things that you do are create a data set version. So you have like a locked in time example image in data set. And we can train a model. And once we have a model trained, everything that we saw on Universe is live. I have like a API I can use or a model I can call in browser. Yeah.
Where is the part where you actually select the model that's used? Is that just like select it automatically or?
Yeah. Good question. So I'll go ahead here and like just create an example dataset version so we can see.
Okay.
So I'll call this like, I added like 3x augmentation. So now I have this version, V1 of my dataset where I've applied basically like data cleaning and data augmentation to go from those source 20 images to now you'll see I have 42 images in my training set because we randomly zoomed in on some of the images was the pre-processing and augmentation steps we selected.
Oh, interesting.
Yeah.
What does that do? Does that just like create like more variance for the model to consume just by like randomly zooming in on different parts of these training images?
Exactly. Yeah. So the name of the game when you have like a small data set in particular is like using augmentation to simulate conditions that your model might see in the real world. So like if we're playing chess, the room could be randomly brighter or darker by some arbitrary amount, or maybe the maybe the pieces have a little bit more saturation. It's almost like you can think about it like almost applying Instagram filters to a bunch of images.
That's cool. So for those listening at home, there's kind of this new little UI that automatically applies these like transformations, like, making the image brighter or rotating it by 90 degrees or like occluding the object, using like a black box or something like that. So that's pretty cool.
Yeah. So all these variants are things that I can apply. And then when we go to the generate stuff, that's when you can choose how many image versions you want to generate. So an example, one image could become 3 images where that one image turns into 3 variants. One of those variants could be a little bit brighter. One of those variants could be like zoomed in a little bit. Those sorts of ideas. But then once I have like my data set kind of randomly messed up, like deliberately I've perturbed my data a little bit. This is where I can train. And so there's a couple of different ways I could train. Like I could ask Roboflow to just pick a model and train for me, kind of like an AutoML solution, and train either like from scratch or from a checkpoint. Or I could train this with my own infrastructure. And we have like a model zoo that users can use to basically like select any of these architectures that play nicely with Roboflow. And you could use the Roboflow pip package, to then like pull those up.
That's awesome.
So here, for example, I'll have to revoke my key after this screen share. Oh, wait, I forgot. We added a little feature here where it automatically blacks out my key when I'm screen sharing for things like this.
Oh, that's awesome. You thought of it all.
But yeah, it's like if I copied this code snippet, then I could paste this directly into, my training pipeline for any of these models that I might be interested in.
Yep.
And then it'll pull the data in, host it on Roboflow, but then download directly to wherever I'm doing my model training.
Yeah. That's awesome. Basically, like you point and clickified the whole kind of computer vision training process.
Yeah. Yeah. And it kind of depends on like the interesting thing with like developer tools is like what level of granularity, like allowing the user to be met where they are, in a sense of like what level of depth they want to go into. So some users might want to toy around with specific architectures from the library. Some users might say, I just want like the API for my model. Give me the API and I'm happy and able to continue about my process by adding vision to my product. And so it's like kind of an interesting like design consideration to make it easy for all those different levels of depth that someone wants to tune and customize be supported.
This is really cool. I mean, it feels like this space is moving just so fast. And the thing that I'm reminded of is, did you ever watch Silicon Valley, the HBO TV show?
I have seen.
And they had that character Jin Yang who made the hot dog not hot dog mobile app at one point, and all the thing did was detect if something was a hot dog or not a hot dog. But like that was a joke I think you could make a couple of years back, and it was still like haha, like computer vision is hard, and this is kind of like the best we can do. But now it's like, well, you should just go and upload a bunch of hot dog photos to Roboflow and point click his way to a working application.
Open invite for someone to put the hot dog, no hot dog model on Roboflow Universe.
That's guaranteed to be a crowd pleaser, I think.
Definitely. We'll see if someone doesn't get to it by the time this episode comes out. That seems like a pretty classic one.
Awesome. Well, we're coming up here on the end of the hour. What's like one or two things that are kind of upcoming for the company or the product that you're excited about?
One of the big things is this community that we launched is actually relatively nascent. And so while I mentioned that there's been like 50,000 people that have built with Roboflow, the default Roboflow experience for the longest time has been the data is private to your account. The Roboflow team can't see it. The broader world can't see it. And that's deliberate and by design, where it's kind of like a privacy-centric experience, especially for like business use cases. What we've been surprised by is like the amount of the community that does treat this like the open source movement and basically like enabling folks to benefit from one another's creations. And I think that we're so much in the first innings of what that looks like. So we at Roboflow have seen this wide, diverse array of use cases of folks working on things that accelerate medical packaging, like for Pfizer, which, has been an extremely important problem in the last year. To actually, we had another company that was creating chest scan models for identifying if like the presence of COVID was there or not. Like in the very early pandemic, it was tough to find tests. And people were using just traditional chest scans to see like how cloudy it looked in someone's lungs. And if it was particularly cloudy, then they would be administered a COVID test. And if they weren't, then they would use the COVID test for someone that might be more needing. And it's small things like that which stretch the imagination of what's possible. And so it's like both the broad swath and excitement of these things that we see at Roboflow, but other people seeing that of all the ways vision's going to be useful. And then ushering that in to be easier, right? So there's the ability for folks to, if a hospital in Boston makes this better COVID scanning identification product, then allow that to be used everywhere else more quickly. So that's one thing I'm like especially excited about is building the community and the depth as well as breadth around that of just how long the tails will get. Another thing that like is this kind of independent of Roboflow is just, you mentioned this, but the rate at which the ecosystem is moving. So, in the existence of Roboflow, YOLO v3 was out, then YOLO v4 came out, then YOLO v5 came out. Clip
YOLO's a like common computer vision model.
Yeah, sorry. YOLO stands for you only look once. Originally published by Joseph Redman. And if we had another minute, I'd pull up his resume, but I encourage your viewers to Google Joseph Redman. I'll spoil it. There's
unicorns on it.
My Little Ponies everywhere.
Like My Little Pony, yes. Sorry.
But the broader like meta point here is model progression is happening so quickly that we still have like narrow AI generally. I mean, you have to really kind of specifically define your task, but it's getting more and more applicable with less and less individual effort. And so it becomes a question of like, how do you make the developer experience better to make use of those sorts of products where we're kind of staking our claim in future. But like, that's a very exciting sort of future of like where all of these what seemingly look like unstructured data problems in the world around us become structured problems. You can make so many things programmable that we didn't think before. And so like the rate at which model improvement happens, the rate at which you don't need to have custom data to start to use vision in your products. And basically like for us at Roboflow, what that means is making it be easier and easier to start to enable applications to see and understand the world and make use of this cutting edge architecture without really having to, become an expert in PhD in vision. And I think that's like a broad trend that's just going to continue to accelerate over the next, it's going to be very funny what the world looks like in the next 5 years. And then looking out a bit further, there's been jokes about this recently on Twitter and whatnot. And sometimes they like hit a little too close to home. People are like, just add the word metaverse to like what you're describing, and like your company does better. And the joke is that like Brad and I have been working on that since like 2017 of like the blended mixed reality of interacting with things around you. And it feels like we're like finally getting closer. And it shouldn't just be Facebook that has the ability to like usher in that future. And so like arming the rebels, so to speak, so that like any engineer and team can start to mesh reality of making things programmable is something that kind of is a trend that I'm looking at in like broader 5-year time horizon.
Awesome. If there's someone listening to this and they're a rebel and they want to arm themselves with this new technology, what's the best way to get into Roboflow?
Free to sign up, roboflow.com or app.roboflow.com. We do our best to maintain good docs, but people can email me directly, joseph.nelson@roboflow.com if things can be made better. We're always eager for feedback. I guess maybe I should tell you to tweet at me at Joseph of Iowa, and we'll get things fixed up. But yeah, try out the app. Yeah. Give us feedback. I think checking out universe.roboflow.com to see if there's models that are already there. Maybe you can make your own hot dog, no hot dog, or raccoon detector. Sky's the limit.
Awesome. We'll drop links to all that in the show notes.
Cool.
But thank you so much, Joseph. This was great. It was enlightening, and I really love the tech that you're working on.
Appreciate it. It was a lot of fun. Thanks for having me.